Okay, to begin with today, you're going to be able to write an equation like this. Really, they look super complicated for a real world situation. Like I could say, for instance, there's a submarine that's oscillating back and forth between like only 2 feet below the surface all the way down to 30 feet below the surface, and it just keeps oscillating. A kid brought up that whales do that, and it's right. Why do whales always come back up? They have to breathe. Yeah, they can't stay down for that long. They can stay down pretty long, but eventually they have to come up and get air. And so it's particularly sad if whales get trapped underneath ice. They're pretty strong, so if it's really thin ice, they can just kind of break through it and breathe. But if they get trapped under big ice, then they're done. All right, so yeah, a whale, for example, could have, generally, they're doing this all day long. You know what I mean? Unless they stay up at the surface, which sometimes happens. But they're coming up for air. And let's say that the up for air part is like right here. And maybe this time he jumped out of the water a little bit, which they do sometimes. So anyway, you can write a pretty complicated equation. And what you need is 2 points. You need a high spot and a low spot. If you can get a high spot and a low spot, you can write one of these equations. All right, so I want to give you, I just want to give you the big picture that that's what we're learning how to do today is write what's called a sinusoidal. And we have found that cosine is the best one to use for these because it really helps with the shift part. All right, so here we go. Imagine for a moment that you had normal cosine. Except, wait, this one's been shifted up a lot. And if I continued it, of course, it would keep going, you know, but I'm going to stop it right there at the end of one period of cosine. And let's say that what we have here is the height of water over time. I mean the height of water. Well, we're used to like Lake Minnetonka. Maybe the lake level will go up a foot or something. Nothing real dramatic. Okay, but what happens at the ocean? Tides. They'll come in and out, and the water level will be rising or falling all day long. It just never stops. It's either at it's low tide, or it's at a high tide, or it's somewhere in between. So let's say that this starts at like in the middle of the night, 12 a.m. Okay, so we start, and we happen to have a high tide at exactly that moment, which is going to be pretty rare. I'll teach you later how to do it when it's more complicated, but we start at midnight, and right in the middle of the night, you have a high tide, and then like, let's say 3 hours later, at 3 a.m., you got this low tide amount. Well, is there still water? Yeah. And let's say this is the depth of the water, which you could measure on a post. You know, if there's a post that's always in the water, you could tell how deep the water is on that post. So let's say that it's 20 feet here, and it's 4 feet there. Now, if I went off to the side and made an XY chart, would you get that X was the time, and at 0 time, is that actually a thing? Yes. In the military, they use military time. It's 0 through 24. Okay, so if you're at 2300, that's 11 o'clock at night. Okay, or 0 is at midnight, also known as like the very beginning of the day, you could say. All right, so 0 goes with what here? What should go right here? 20. And then what goes with what? 3 a.m. goes with 4 feet deep. Now, I could have more data than that. They could give me more data, and sometimes they do that just to like make the problem more rich. Here's a ton of data, but do you get what you really want? Is the high spot and a low spot? Okay, now to get one of these kind of equations, y equals, I'm going to always be referring to a, b, c, and d, so I want to remind you how that works. A cosine of b parentheses, I'm going to use theta minus, what do you think is coming next? C, and then what do you think is at the end? Plus D. Very good. Okay. And we're going to show you, I'm going to show you how to get A, B, C, and D. All right, first up, this dotted line that runs right down the middle is really key. I call that the center line. Why? Because see if your brain can do this. If I shifted everything down and made the dotted line be right at 0, do you get it would be normal cosine? So that dotted line really tells you how much it's been shifted up. And now, where is the dotted line? It happens to be, well, exactly between 4 and 20. What would be exactly between 4 and 20? Well, it would be the average of 4 and 20. Add them together, divide by 2. You get 24 divided by 2. What is it? 12. All right, so 12 is a key number. Who knows what it is? It's D. It's how much this sinusoidal, which even though it's made out of cosine, we call it a sinusoidal, is shifted up. It's been shifted up that, which is 12. That's 12. And so is this distance that's been shifted up. So I'm putting a 12 right there. Yay, I got 1/4 of it done. Now, how about the amplitude? Do you remember the amplitude had to do with how big the wave is? I hope you remember. I don't know if you will or not, but it's this distance from the center up. So from 12 up to 20, which would be 8. The amplitude is 8. Boom. See how the dotted line gave you 2 of your 4 things? That's center line. Because the amplitude is how far it is from here to here. And it's 8 that way, and it's 8 that way. Some people mistakenly think that it's 16, but the amplitude is just from the center line up. Okay. Now, B and C. All right. I made this an easy one because cosine, you get how the peak of cosine is supposed to be right there, and it is right there. So I don't have to worry about any shift. So what is C equal to? 0. Now watch what would happen if I take my blue line and I shift it over like this. Then do you get, I'd still need the low spot, the high spot, and everything, and I'd also need to know how far over it got shifted. We'll do that on the next one that we do, okay? Because this one didn't get shifted over like that. So cool, we don't have to worry about C. I gave you a little break on the first one. All right, and last, we're just in a blank notability doc. So, and last but not least, the B term. There's a formula for that. Do you remember? It's something equals something over something. 2 pi is involved, yes. What's it start with? Say the whole thing. Period equals 2 pi over B. Awesome. Now, I definitely don't know B. That means I must somehow know what the period of this thing is. Would you agree that if I knew from here to here and how long that was, then I would know the period? That's the point. That's what the period is. Well, I don't know that whole thing, but I do know that from here to here took how long? 3 hours, and therefore how long would the period be? 6. So then I put in a 6, and I can figure out what B is. 6 equals 2 pi over B. So then I'm going to multiply both sides by B. Cancels. 6B equals 2 pi. Dividing both sides by 6. B equals 2 pi over 6. Simplifying, pi over 3. And some of you are like, oh, sweet, so it's 60 degrees. Well, not necessarily. Pi over 3 is just 3.14 over 3. Pi doesn't mean radians. Pi means 3.14. So this B term is pi over 3, which doesn't mean it's an angle. It means that's about 1. Think about it. Isn't about 3.14 divided by 3, isn't that pretty much 1? pretty much 3 divided by 3, right? Okay, so that means that this doesn't have very much of a stretch to it, horizontal stretch or shrink. It's only pretty much a 1 in there. All right, so hey, I've got it. And if I had shifted it over, if this whole thing had been over here, then I would have told you that the first peak was at like 3 a.m. Let's do that. Let's say I moved it over here. If the first peak was at 3 a.m., then I would have been able to say that it was shifted. How far would this be? Well, 3. So theta minus 3. If the problem had been shifted over like that. That's the only thing you do is say how far over is this peak here been shifted from where cosine normally has its peak. It's been shifted that far. And you need to know the x value of that first peak, and it goes there. Okay, now let's see if you processed all that. Because they're difficult. This is one of the reasons why the test isn't tomorrow or the next day. It's the day after that. Okay, so it's okay if you haven't got this yet. This one's going to be a wave that has been shifted. Do you get that it's not a perfect cosine graph because it didn't start, wait a minute. It didn't start at the peak. Does that make sense to you? If the cosine had started here, there would not have been a shift. It wouldn't have been shifted to the right because that's how cosine normally starts. Cosine starts at 1. You know, cosine normally looks like this. So if this one's been shifted over a little bit, now you got to deal with that shift thing. We're going to do the same exact time. We're just going to keep it simple. This is depth of the ocean. And we're going to say at 2 a.m. that the water was at 30 feet deep in the harbor. The harbor master's trying to figure out a formula for this so that he knows there are some super tankers that need really a lot of depth of water to be able to sail into the harbor because otherwise they're going to scrape on the bottom and they don't want that. It's called the draft. So if he wants this formula made so that he can know at any given time, how deep is it? All right, so we start at 2 a.m. with the 30, and let's say that at 6 a.m. you're at the low tide, and that's at like 20. And if it was at 20, that ship would run aground. It wouldn't be able to, you know, it would get stuck. So he needs to know a little formula for saying what time is it, and therefore how deep is the water. That's what this formula will do. I now just gave you 2 points. If I was saying it in terms of an XY chart, I'd be saying at 2 a.m. it's 30, and at 6 a.m., I don't need the a.m. part, I'll just write 6. 2 was 30, and 6 was 20. And then it would oscillate back and forth. On your homework and test questions, a lot of times they have extra points on the XY chart. They might have had something in between. Would you agree that there would have been a depth at 3 a.m.? And it might have been something less than 30, like 26 or something. But you just kind of ignore that because all you care about is the highest and the lowest. You wouldn't care what was in between times. Okay. You've got everything you need. You should be able to write the whole thing out. And do you remember how I started last time? What was that dotted line that ran, what was it called again? Center line. Find the center line. All right, you should be able to write me the whole equation. I'm going to pause for a second while you give that a try. Check with the kid next to you if you're stuck on certain parts. Even if you're stuck right away, just ask, get some help. I'll pause while you try. Okay. Here's how you at least start. That dotted line right down the middle, that was at 25. If you want to know, it would just be averaging these two. Okay? Then, if that's 25, then right away I know not A, but I'm going to make it A cosine B theta minus C plus D. Then the dotted line is D. So this is 25. Okay. Tell me what to do next. Front row. Tell me something else you can do.
I did 5 for A.
A is 5. How'd you get that?
I just did 25.
All right, awesome. That is 5, and so therefore there's a 5 there. It's called the, do you happen to know? There's an AMP. There you go, amplitude. And then B, that's that part, has its own special formula. Do you know it, sir?
Pi over
What's 2 pi over?
period.
Period equals 2 pi over B. Awesome. And what is the period? Because I don't know B, I must know the period. How do you get the period then? Common mistake answer is, I think the period is 4. Can you tell me why that would be wrong? You don't start from 0. You start from the high spot and you go to the low spot, and that is 4 hours. Why isn't that the right answer? It has to be a full wave, and aren't we only halfway through with the wave? And so if 4 will get you halfway, what's the final answer? 8. The period was 8. How many of you knew that the period was 8? Okay. If you didn't catch that, that might be one of the hardest parts. You're just finding this distance, which was 6 minus the 2, and then you have to double it because you're only halfway through. Now you're at a complete cycle, and that would be a total of 8. So then if I solve for B, it'll be 8B equals 2 pi. I'm just multiplied both sides by B. And then I get B is 2 pi over 8, also known as pi over 4. And the pi over 4 goes right there. Pi over 4. My 4 looks weird. I'm going to fix it. Pi over 4. Okay. And the last thing is the shift. What did you get, LW? How'd you get it? That spot's the x value of the highest spot. It's the x value of the first peak is the way I'd like to say it. Is 2. There we go. How many of you had that one totally right? All right. If there was a part you want, is there any part you want re-explained? Like, I'm not sure how you got that. Okay. All right. Now imagine for a moment I didn't give you a picture. I just gave you data. Let's say at 1 a.m. it was 8 feet deep. At 2 it was 9. At 3 it was 10. At 4 it was back down to 9. At 5 it was back down to 8. At 6 it was down to 7 feet deep. At 7 it went back up to 8 feet deep. That's kind of confusing. But look through it. Do you see that the water level seems to be just rising and falling and then rising again and stuff? All right. What you look for is the first peak. Do you see the first peak? If you do, call that number out. And then if I were you, I would always make myself a little picture, and I'd have a little wave, and I would find these 2 spots, because a picture's worth 1,000 words. If you're just looking at this chart and they say, where's the center line? You'd be like, what are you even talking about? But if I show you this chart, you'll know the center line is the one that runs down there, right? Okay, so let's make a little picture and figure out where's the first peak and where's the first valley. Figure out which are the key ones. RS, do you have them? What was the first peak? 310. Okay, so then this spot is at 3, 10, which means that's 3 and that's 10. You with me so far? Okay, JN. This spot you're saying is 6, 7. So then I'm saying that is at 6 and that is at 7. Okay, awesome. And that does appear to be the next low spot, the valley. Okay, then EL, tell me what to do to write the equation. I agree. Center line runs right down there, and this isn't the nice one, but you can do it.
I would say 8.
8.5 is correct, sir. And then that means that your A cosine B theta minus C plus D, which part did we just figure out? False. We can figure out A. D. And that is what? I'm going to come back to you when your brain is fully functional. It's okay. It's all right. You're just getting things backwards, so I'll come back to you. All right, JS, second to the front row. Where does the 8.5 go? Yes. Now, it does fairly quickly tell us the A, the amplitude, but the amplitude isn't 8.5. What is the amplitude? Let's go to the back corner, CA. You're trying to find A for me. How'd you get it? I like that way of saying it. Okay, so go from there to there, and that was 1.5. So you're saying I should put a 1.5 right there, right? Okay. All right. Next up, WB. Tell me what to do. Okay, I'm going to help you then, and we'll work through it. This part right here is how far over it's been shifted. Look at the high spot right here. If that high spot was over here, this would be cosine without a shift. So the difference is how far that got moved. So that 3 is the x value of the first peak goes here. You are correct. And then, last but not least, OC, the B term. How'd you get that, though? Period equals 2 pi over B. And you said that the B was 6. How did you get that so fast? I'm not saying you're wrong. I'm just asking. Oh, so the period should be 6? Okay. So then how did you get that? How did you decide that the period was 6? I'm only seeing 3. Halfway is 3, then the whole thing must be 6. I agree. And then the final answer when you flip-flop these two would be B equals 2 pi over 6. B equals pi over 3. So that pi over 3 goes right here. And you got it. All right. Now, do you get how I made it a little more obscure by just giving you data? But then I immediately drew a picture. All right, here's one that's even more obscure. A Ferris wheel. How is a Ferris wheel kind of like a sine curve? If you watch my marker here, do you get my marker has, I'm rotating it for those at home, around in a circle like a Ferris wheel. Do you get it's got a low point and a high point? And then a low point, and then a high point, and then a low. So it's a lot like a sine wave. Okay, so it has a low point that it reaches. Now, do they actually touch the ground? Well, no, because then they'd be dragging on the ground every time they went around. That wouldn't be good. So let's say that the thing is 4 feet off the ground at its lowest point. Probably not 4 feet, but whatever it is. Okay. And then at its highest point, it's, let's say, 54 feet. And let's say that we start this at minute 3. It's down here. And then at minute, how long do you think it takes to get up to the top of a Ferris wheel? Probably depends on how big the Ferris wheel is, right? There's a giant one in London. Have you heard of the London? Anybody know what that is? The Eye, yes. Anybody actually been on it? Cool. So was it cool? All right. How, like, ballpark for me? Is it? Do you feel like it was like a football field off the ground, like 300 feet? Does it, you feel like it's even higher? Okay. 200, 300 feet, something like that. Okay, it's pretty high. All right. So this one's pretty much a baby one. And let's say that this one, we'll keep it simple. It takes 1 minute to get to the top. Is that a complete cycle? No. Yes. Oh, it's 400 and some feet high? 443? Thank you. So it's something that's not hard to Google. All right. All right. So do you get I just gave you 2 pieces of data? Just like I could have on a chart, like an XY chart. It's just I thankfully just gave you the ones you needed. If I were you, I'd still make a little picture of a wave. I know this really isn't a wave, but it still would help if you had your little wave like this, and then you'd find the first high spot, first low spot, and what times they were. Then you could make it just like all the other problems. All right. Do it. You can write an equation for this. I'd make the little picture, then write an equation for this word problem that's going to end up giving you a sinusoidal equation. So the suggestion by a kid was find the center line that runs right through the middle, and then that'll help you tell you D and A. Pause while you go further. Okay, let's see if you did it right. The lowest it went was 4. The highest was 54. What's exactly in between? I have them together divided by 2. And if I have them together and divide by 2, that should be 30.
No, 58 divided by 2.
Oh, it's 58. Thank you. Okay. All right. Can anybody verify 29 is the line that runs down the middle? All right. Then that means it's been shifted up 29. That means that this is a 29. Then from 29 to 54, that means they're 25, right? Personally, I like to think of this as going from the center line up. And yes, it's the same thing as going down, but down usually has a negative going with it. So it's a little safer for me to say from the middle line up. Okay, and then that's not 30. What did I just say it was a second ago? What? The A term, the 25. There we go. Okay, and then the B is that little formula, which is period equals 2 pi over B. And then the B term, I don't know, but I know the period. The period is from here to here, which is from minute 3 to minute 4, which would be 1 minute. No, it's got to be that doubled. So it's 2 minutes. So this is a 2. So then I'm dividing by, and it becomes pi. Raise your hand if you had pi right there. Good. And then the last thing is the shift. That's the x value of that, how far this got moved over to the right. So it's the x value of the first peak, which is, the first peak was here. So it's the x value of that, which is the time. So it's 4. That's 4. Yes.
Couldn't you say that it was also at the top at 2 minutes, and then at 1 minute it was down at the bottom, and then at 0 it was also at the top, so you didn't need it?
So are you saying that you could shift it over, since the period was, what was the period again? 2. So since the period was 2, we could go back 2 and it'd be in the same place, and back 2 more and it'd be in the same place. So actually, this answer, it's kind of a pain in the butt on the test to grade these. That could be 4, or since the period is 2, it could be 2, or it could be 0, or it could be 6, or it could be 8, or it could be a lot of things. Yes. But how about this? Is this the x value of the first time that in my data that it hit that? Yeah, we don't know technically that it was running at time 0. You know what I'm saying? It might not have been running at time 2. It might have started at time 3. Okay, so the safest thing to say is that number because it's the x value of the first peak. And I know you can subtract 2 from it because that's every 2 minutes it's going to be back at the top. But the ones that all we know is that it started at minute 3. It might not have been running before that. All right, Sue. 12 minutes left. Time to get your homework. So, do you have questions about this? I'm happy to help. Yes. Which part, the A, B, C, or D? Okay. And that was, if I made a list of my times, would you agree minute 3, it was at 4 feet, and at minute 4, it was at 54 feet? What I'm trying to train you to do is find the first peak and take the x value of the first peak. This was the first highest time that I told you height-wise, and it's the first time it hit that. We don't even know when this thing started. Some of you guys are assuming it started at time 0, but that assumes that the merry-go-round, or whatever this thing is running all day long. Maybe they turned it on at time 3. So this was the first peak, so you take that and you put it there. It's just the x value of the first peak. Now it is true that if this thing had been running all day, then it would have been at height 2, and height 0 would have been also right answers. But all right, enough about that. Your homework for tonight. I'm only giving you 2. They are nasty, beastie word problems, but there's only 2 of them. One is specifically about the London Eye. My daughter got a chance to go on that too when she visited London for her honeymoon. I'll have to ask her more about that, because I didn't get too much of that story yet. And then the other one's about the moon. Skip the one in between. Do the London Eye, which is the one kind of like we just did, and the moon. I always recommend you use cosine. Technically, you could do sine, but then the shift is harder to figure out. Cosine, you just have to look for that first peak. Okay, so it's just these 2. The moon one, you can skip that one, and the London Eye question. And they called it h of t. I had said y equals before, but that's like f of x or y, and it doesn't really matter what you call it at the beginning. That's okay to use h of t or y equals. All right. And one thing that kids tend to ignore this because they think it's extra work. I'm telling you, kids that draw this and put in their high spot and low spot often do better on this. And I want you to do well. It's a lot easier to grade A tests. Tests that are A's are easier to grade. Make a little picture like that and label your high spot and your low spot. It's so much easier. Then you can basically turn everything into like a tied question. All right. And that's all I have for you for today.